All right, here we're going to be talking about two parts of circles. One is called an arc. The second is called a sector. So those are just going to be two different parts of a circle that we need to be familiar with. An arc is going around the outside of the circle. It's a portion of the circumference of a circle. So the circumference of a circle is going around the outside of that circle. Really, it's the distance going around the outside. An arc, like you see here, is just part of that. There's two different measurements that are associated with an arc. The arc length is the actual distance itself. So if you want to figure out the distance from A to B, that's called the arc length. It's the distance between those 2 points. So the arc measure is really referring to the angle that creates that arc. So we know that a full circle is 360 degrees. This portion of the circle represents some number of degrees out of that 360. And it's equal to the central angle that intercepts that arc. The central angle always starts at the center, and it goes out to the outside of the circle. So here, that central angle is AOB. That angle is the central angle. That's going to have an angle measurement, and that angle measurement is going to be the same as the arc measure of AB. When we write an arc, we kind of write it exactly like we write a line by the two endpoints. So A and B are the two endpoints, but instead of putting a line over it, we put the little arc symbol over it. So that is arc AB. So now we're going to find a couple measurements based off of AO being 5. So that distance is 5. And angle AOB is 72 degrees. So this angle is 72 degrees. So we're given the radius and that central angle. We're going to find the circumference of circle O. A circle is always named by its center. Circumference is just a formula on your formula sheet. There's two of them. There's pi times diameter, or the one that I'm going to use in this case is 2 times pi times r. You can see that those are the same. 2 times r is the exact same thing as the diameter. I'm going to use the bottom one just because that's what I'm given. I'm given the radius here of 5. So I'm going to plug that in to find the circumference. 2 times pi times 5 would give me 31.4. I'm just going to always round pi to 3.14 just for simplicity. And actually, that's what the SOL does. There's also something else I want you to be familiar with here. A lot of the times next year, you're going to leave things in terms of pi. So actually, instead of even multiplying that out, you're going to leave this as 10 pi. You could really write your answer either way during this class. I think a lot of you are going to be more comfortable with that written as a decimal. But you're going to see this a lot next year. And the reason we really do that is because pi is an irrational number. We don't really want to have to deal with decimals that look like that. We'd much rather deal with it just with a simple whole number, like 10, and then deal with it in terms of pi rather than having to multiply pi out each time. It's also because radians are measured in pi, but you'll get to that later. So that's the full circumference of the circle. Now I want to think about the measure of arc AB. Remember, the arc measure is just a number of degrees, and it's equal to the central angle. So that's going to be 72 degrees also. The length of AB is the distance going from A to B along the edge of that circle. So here we want to think about what portion of the circle is AB. Well, we know that it's a total of 360 degrees, and this is 72 degrees out of that 360. So we know that this arc is measured by 72 out of 360. We want to figure out what portion of the total circumference, how much of the 31.4 does that 72 degrees actually account for. So these are proportional. Actually, that's what we're about to get to here. The arc measure and how it relates to the total 360 degrees is proportional to the arc length and how it relates to the total circumference. The arc measure out of 360 is the same as the arc length compared to the circumference. Just some portion of that circle. So we're going to cross multiply and solve for that x. So we'll multiply 72 times 31.4, which would give me 2,260.8. And then we cross multiply here also, 360 times x And then we'll divide by that 360 to give us that x is 6.28. Always make sure that that really makes sense. It can't be bigger than 31.4 because that's the total circumference. 6.28 is some part of that 31.4. It turns out that it's 1/5, just like this is. That is 1/5 of the circle. That's also 1/5 of the circle. We're just talking about different parts of it, whereas one's talking about the measure of the actual angle, the other's talking about the arc length. All right, so we're going to use that proportion in a few different ways here. Trying to find the arc length of AB here. The arc length is the distance from A to B. We're given the radius, and we're given the central angle. So we know that the angle measure, the arc measure really, is 60 out of 360. And that equals some arc length out of the total circumference, which we don't really have yet. We have to find that. So we're going to do 2 times pi times the radius of 8. So that's going to be 16 pi. We left that in terms of pi. Or we can multiply that out and get 50.24. And there you're going to cross multiply. 60 times 50.24. And then we'll divide that by 360 to find out that that distance is 8.37 centimeters. If you wanted to use different logic, you could think, well, 60 is 1/6 of 360. So if you wanted to, you could actually just do 1/6 times the total circumference and get this exact same answer. There's other ways to think about this proportion. I think it's going to be simplest for right now to actually set up a proportion where you're comparing those two equal parts. All right, now we're trying to find the circumference of circle Z. So we know the arc length right now, and we know the central angle or the arc measure. We know that's 40 degrees out of 360, and that equals the arc length, 4.19, out of the total circumference. So we can cross multiply and solve for that circumference directly. To be honest, that's not the way I'm thinking about this. I'm thinking, well, 40 degrees is 1/9 of 360 degrees. If I just added 40 degrees together 9 times, that would give me the full circle. So really what I would do is just 4.19 times 9, which is exactly what we're finding here. And that would give us that the total circumference is 37.71 inches. All right, now we're trying to find the measure of our RZ, which is talking about an angle. We're looking for an angle measurement. Did I say RZ? I meant RS. We're looking for this. Anytime we're talking about an arc, if it's just referencing our RS, it seems like we could go either way. We can go this way, or we can go this way with it. It's always talking about the smaller one. It's called the minor arc. We're always talking about the smaller side. Here I think it's clear because the 44 is on that side. But anytime we're just given an arc, it's got to be talking about just the minor arc or the smaller part, the smaller portion of the circle. So the 15.28 is pointing at the radius. The 44 meters is talking about this arc length. We're trying to find the measure of that angle. So I don't know the measure of the angle right now, but I know it's out of a total of 360. And then I know it's equal to 44 out of the total circumference. That's the number that I actually need to find before I can solve this proportion. So 15.28 is the radius. I'm going to do that times 2 and then times pi. Find out that my full circumference is 95.96. So 44 out of 95.96 is the same thing as whatever that arc measure is out of 360. So we can cross multiply and solve for that arc measure. That is 165.1 degrees. Again, that kind of makes sense. As you can see in that picture, it's less than 180. All right, the second part of the circle that we need to talk about is a sector. A sector is also a portion of a circle, but now we're talking about the area of the circle. So we can talk about the minor sector versus the major sector. Actually, we're almost always going to be talking about the minor sector. Anytime we just talk about a sector in general or an arc in general, it's talking about the minor sector or minor arc. It's the smaller portion of the circle. When we talk about sectors, you can actually refer to them in two different ways, either by the 4 points that are creating the arc. So we start with O, then go to A, then go to X, then go to B. That's the minor arc, O, A, X, B, minor sector. And the major one is also starting at O, then going to A, then going to Y, and then going to B. We don't necessarily need to use all 4 of those. Sometimes you'll see it without this point. So if you're not referencing either X or Y, then you're going to be talking about the minor sector, because you could just say O to A to B, and that could be talking about that direction or that direction. If there's no 4th letter included, you're really just going to be talking about the minor sector. All right, so we have the same measurements as before. AO is 5. AOB is 72 degrees. What's the area of the circle? So area is pi r squared, pi times 25 is 78.5. So that's the total area. We're going to use a very similar proportion for the area of the sector. It's still just thinking about some portion of that circle. It's 72 degrees out of 360. And that equals some number out of 78.5, out of the total area. Again, if you're more comfortable thinking about this as like a portion of that circle, 72 degrees, I know that's 1/5 of that circle. So you could just do 1/5 times 78.5, or you can set up a proportion and cross multiply and find out that this sector has an area of 15.7. We don't have any units. I'm going to call it just units squared because we're talking about area. Same kind of proportion, except now we're dealing with area. So the arc measure out of 360 is equal to the sector area out of the total area. So on this first example, 40 degrees out of 360 is equal to some portion of the total area, which is going to come from pi times the radius squared. So you're going to need to find the area of the circle before you can plug that in. I'm going to just leave that in terms of pi. That's 324 pi, because I really don't want to have to multiply that out and deal with the decimals. It's much simpler. Then we can cross multiply, and you're kind of dealing with pi as a variable. It's not a variable, it's a constant, but you're kind of dealing with it as a variable here. So you can cross multiply 40 times 324 pi, 360 times x, then you divide by that 360, and you can get 36 pi as your final answer, or if you're more comfortable with decimals, it'd be 113.4 meters squared. All right, we're looking for the area of sector Z, X, Y. We're looking for this area. Right now, we're given the arc length. That 4.19 is the distance from X to Y. And we're given the central angle of 40 degrees. So I'm going to need to somehow get to the radius. I need the radius to solve for the area, the total area, and then from there I can solve for the area of the sector. All right, this is exactly the same circle as what we had before. I'm going to do 4.19 times 9, because I know that 40 degrees is 1/9 of that circle. Could also set up a portion, and you'd find out that the total circumference is 37.71. Now I know circumference is really just 2 times pi times r. So the circumference, or 2 times pi times r, equals 37.71. From there I could solve for the radius, divide away the 2 pi, and we'll find out that the radius is just 6. From that radius, I can solve for the total area. pi times the radius squared, or pi times 36. That's actually what we just said here. That's 113.04. So my total area is 113.04. I have 40 degrees out of the total 360. That equals some area out of the total of 113.04. So there you can cross multiply. If you left this in terms of pi, you'd get 4 pi. Or if you want to change that into decimal, it's 12.56 inches squared. And the last one, we're given the central angle of a sector is 144 degrees. And the sector itself has an area of 15.7. So it's 144 out of 360. And that equals 15.7 out of the total area. I guess I should have read what I'm looking for. I'm trying to find the radius of the circle, which really means I'm going to need to find the total area, which is what I'm going to solve for here. And then I'm going to need to solve the equation for area of a circle for the radius of that circle. So this portion is just going to help me solve for the total area. So we're going to cross multiply there and find out that the total area of the circle is 39.25. Now, if that's the area of the circle and I want to get back to the radius, I can really just plug that into pi r squared as the answer to that equation, and then I will solve that equation for r. So you're going to divide away the pi, you divide by 3.14, and then we're going to take the square root of that answer. Just like in Pythagorean theorem where you finish the problem by taking the square root, you're doing the opposite of squaring something. So take the square root of this number, and we get that the radius is 3.53. Again, no units, but we're just talking about the length of something, so it's just the number of units of 3.53 as the radius.